What is up, Brad fans? How you doing? How you living? The more I continue on this path of science communication, science journalism, the more I'm firmly convinced about science being really a human endeavor that, like other human endeavors such as art, is really influenced by the people that do it, their perspective, their background, their environment, where they come from, all of these things. And that's why when I saw the article by my guest today, which was calling for more science communication in Africa, in Kenya specifically, I knew I had to get Dr. Patience Kiyuka on the podcast. Dr. Kiyuka is a principal scientist at the Kenya Medical Research Institute, and as you'll hear, her work really follows a path from the body, the biology, the immune system, to the patient, to the population, to the community, where she's focused on diseases like malaria and finding treatments that work for the communities where malaria occurs. You'll also hear how her background, her experience growing up with malaria really influenced what she wanted to do with her career. And the community is also her focus when it comes to science communication, helping them understand what it is that the researchers are doing and how they're trying to help. Aside from her academic accomplishments, she's also received several awards for her science communication, including the National Academy's Eric and Wendy Schmidt Award, and also she was recognized by National Geographic as a National Geographic Explorer. It was really great to talk to her about her background growing up, how she decided to become a scientist, what she feels about science communication, the importance of science communication in Africa and globally, and her experience traveling around and having international collaborators. This was another reason that I really wanted to have her on because, again, our perception of science is this cold machine that just plucks facts from the air couldn't be further from the truth. But another stereotype we have about science is of the old white guy in a lab coat. And I admit that I'm guilty of it too in my work. It just, the things that I see naturally come from Europe and North America. But again, there's so much great science that's happening around the world that's influenced by the people in these local areas, and they have a very unique and valid perspective that I would love to learn more about. We discuss this, how international relationships sometimes still carry this little brother, big brother connotation. It's changing a little bit as we hear from Dr. Kiyuka, but it could still get better. It was a really great conversation. I really enjoyed speaking with her, and I encourage you to follow the links in the show notes to check out all of her work and science communication work. And of course, leave us a like, follow, subscribe, wherever you're seeing this on YouTube or your podcast platform. Reach out on social media at 2bradforyou on Instagram, or shoot us an email, 2bradforyou@gmail.com. You can always leave a comment as well. We'd love to hear from you. Now, let's get to the conversation with Patience Kiyuka. Hello, Patience. Thank you for being here. How are you doing today?
Good. Thank you for having me.
Yeah, no problem. I'm excited to speak with you because as we kind of talked about off air, science journalism, I've been more and more interested in wanting to understand how science is being done in other places. We always think of Europe and North America, the Western countries, so to speak, and we don't often think enough about the other places where people are doing interesting work, interesting science, and importantly, have a different perspective than, what the rest of us have or what people in these other places have. So thank you for taking the time. I really appreciate it. And maybe the best way to start is you can give us your short bio, where it is you're working right now, and what are the kind of things that you're researching right now. And then we'll rewind and look at how you got there.
Yeah, thank you for having me. My name is Patience Kiyuka. I'm a research scientist, or what you'll say a postdoc, at Kenya Medical Research Institute. We have several centers in Kenya, and my work is based at the center along the Indian Ocean in Kilifi called Center for Geographical Medicine Research Coast. So I I describe myself as a transdisciplinary, researcher or multidisciplinary researcher. So my work is generally around infectious diseases. So I like to split it into three parts. So I look at the molecular epidemiology of diseases, understanding how diseases are introduced in the population, how they are sustained in the population, so that can inform that epidemiological understanding of the diseases helps us to design interventions around these diseases. You think about arboviruses, for example, dengue, chikungunya, and all those viruses, and then you have respiratory viruses like RSV. And then you also have parasitic infections like malaria. Then my other segment of my studies looks at how the body reacts to the diseases, understanding the immunology of these diseases. And that is important in trying to design, for example, a vaccine. So you need to understand how does the body interact with the disease, what's the defense mechanism for the body. And that's important in trying to design vaccines to mimic the body, how the body manages the infection. And then I have another, part of my research that looks at, for example, once the interventions are in the population, how do people, what factors influence whether the population takes the interventions? For example, vaccines. There is enough evidence to show that vaccines are important, but we also have overwhelming evidence to show that not everyone takes the vaccine. So no matter how well an intervention is, unless people take it up, that is not as good as not having it. So those are all my facets of my research, if I can call them. Then alongside embedding all that research work I do is science communication. I think now more than ever we need to think about science communication with all these political threats to the way we do science. I think we need to make a case on why we should keep being funded by taxpayers. So science communication is important, and it embeds the work that I do.
Yeah, it's a very comprehensive program, and like you said, transdisciplinary is one way to put it. I think it's very optimistic because you have this, you're tackling the same problem from three different areas, and I think that's really important to get that full scope. I think a lot of times, especially when you do a PhD and stuff like this, as a scientist, you can get very focused on one thing, right? Whether it's the immunology or the epidemiology, but then taking it that next step and saying, well, we've developed these treatments, we've looked at epidemiology, we've looked at immunology, but now are people going to accept the treatment, take the treatment, work with us to roll it out to the people that need it, right? Like, I think that's a very important step and again, I'm just speaking of, my experience, doing academics in Canada and a little bit here in Europe and stuff. We don't think about that last step.
Yeah.
It's always like, oh, here's this great thing that we've done. We'll just put it out there, and of course people will want to use it. And it's only really now, I think, since, well, obviously COVID pandemic, that people in Europe, North America are really starting to be like, oh, maybe we actually have to do a bit more to do this stuff, So it's great that you're doing that. It's really very interesting. I want to then ask, how did you get started in science? Because I researched parasites, so trematode parasites, but not of humans, of animals in my PhD. And I always thought, the people that research parasites or infectious disease or, these kind of topics is a bit of a unique person, because it's kind of a weird thing to get into. But maybe you could tell us, about when you first got into science in general, let's say, and then your specific research questions or focuses that you have now.
Yeah, I mean, I didn't grow up thinking I want to be a scientist because I never interacted with anyone, who was a scientist growing up.
Mm-hmm.
And those years when I was growing up, I mean, we never used to have career discussions with our parents, or these were very foreign discussions to have even in school. So, but the thing is, I knew that, I needed to be somebody. Like I grew up in a place where there was lots of malaria, so I was used to fall sick many times, and which is a disease I later came to study. And I realized that young children can have very many episodes of malaria. So I used to be a very sickly child, if you could say, and I visited hospitals many times, and that fascinated me. I never used to understand why is it that I'm always constantly in the hospital. but it never
Mm-hmm.
occurred to me that, being a scientist would be the way to understand such kind of things. So, so in the village, and it's during those early days, 1990s, Kenya was still a very young country, and there's a lot that was happening in terms of development. So, but I knew really I needed to be somebody, and I was highly motivated to be sort of successful, because I didn't want to feel like I'm not able to, buy the things that I used to see my grandmother struggling to, buy for us. I was brought up by my grandmother. So then I knew I needed
Mm-hmm.
to, really work hard. I grew up knowing that for me to be, for you to be somebody, to be out of poverty, you need to work hard. So that's what I did in school. And up to high school, and then when I finished high school, my performance was I'd say good enough. So then it was now time for me to transition to university. And that time, then you're forced to sort of choose your career, because then it's based on your performance that then you choose the track you want to go to. And I remember my mother saying, you have performed very well in biology, chemistry, these are science courses. You should take a science course. And for sure, biology used to fascinate me. Among all the research science subjects, physics, maths, and biology. For me, biology was the easiest to understand. I mean, I could get almost everything the teacher was saying. So then I chose a course that was, biological. And that's sort of how I went into science in a way. Then I did biochemistry. And then from there, I got attachment to a research institution, sort of building my career towards that. And I've come to love being a scientist. I can't even imagine doing anything else. So
It's a good sign. It's always a good sign when you can't think of what else it is that you would do, that you found the right thing.
yeah, I mean, I find it hard to do one task over and over. And I tend to think like scientists, we are like artists. Because then you get to design. There's just so many ways you can design a study, so many ways you can
Mm-hmm.
iterate a project. And that, constant cycle of you designing a project to implement, and the thrill of looking for funding. I mean, it's very hard to get money. And it's even harder when you're in some parts of this world. So for me, that adrenaline rush to just do this difficult thing, I mean, keeps me awake. I can't imagine doing something every day, the same thing.
Yeah, I think that's, I mean, a lot of people I talk to that are scientists or have done some kind of scientific, PhD, whatever it is, right? That's one of the big things, is that it's every day is different kind of thing. And that creativity that I think that people maybe that haven't worked in a lab, or maybe don't really understand exactly how that works, but it really is a creative pursuit, which I think is really interesting. So you often find people in science that are quite creative, or enjoy, arts and other different things, but their creative outlet, while some of us, the creative outlet is a hobby, right? Creative
Yeah.
outlet is actually built into a scientific career, which, yeah, I understand. Yeah.
Yeah. I think scientists are artists. I mean, I don't know anyone else who gets to create as much as we do. I mean, we are not considered, but I think science is sort of being a creative industry. I mean, sort of, in a way.
Yeah, well, I think more people within science should maybe take that to heart, right? Because it's not something that I think some scientists would readily admit or agree with. They might say, no, that's, it's too abstract, that creative, we're really logical and it's all about this. But if you embrace that sort of, I think, artistic side, let's say, you mentioned writing grants, right? And getting funding. Like, you have to have a bit of a flair for
Yeah,
storytelling in
yeah.
order to, get somebody to agree to give you €1 million, or whatever it is, right? Like, it's no one's just going to hand you that money. So you have to be able to be convincing. And you do that with, here's the story of what I'm going to do, why I want to do it, why it's important, all of that kind of thing. And so maybe if more scientists sort of embrace that sort of role, um, it might it might help with their funding. I don't know.
Yeah,
Maybe that's a
yeah, yeah.
stretch. I don't
But
know.
but but look nowadays, I mean, most funders are moving away from funding one individual. I mean, if you get a grant of 1 million, 2 million, most likely it won't be a grant to one scientist. It will be, a team of scientists. And why? Because now
Mhm.
we need to tackle the same question from different angles. So I think it's embedded in there. Maybe we are not calling it that way, but in a way that we are being scientists are increasingly being forced to work in teams.
Mm-hmm.
answer the question molecular immunology, bring in loop in social scientists so that you have a whole spectrum of scientists answering the same question in different ways. And I think that's where we are moving to. I don't see a funder giving you $5 million to just one scientist to answer the question in one way.
Mm-hmm. Yeah, and that's probably also like a myth that people see from the outside, right? Like the picture of a scientist is that lone individual in the
Yeah,
lab
yeah.
coat, working at the desk or working in the lab or something, and then they have that aha moment, the
Yeah,
eureka
yeah.
moment or whatever, right? And it's like, and I think actually this is difficult because what I do, science journalism, often a story that involves a lot of people, right? Like, because all science involves a lot of people, even to beyond what you just said. Like, there's different labs that collaborate, but within a lab, you have a team of PhD students, postdocs, the PI, the professor, the lab techs. Like there's this big team. But when we write about science journalism, because we're trying to tell it as a story in a concise way, a lot of those individuals don't make it into the story, right? So you in a way you kind yeah it's a bit of yeah a conflict there, but yeah it's I'm not sure how to get around it.
Yeah, yeah. Science is communal. Science is communal.
Yeah, absolutely. So I'm curious then, you mentioned, because I know a lot of people, when you ask their how did you get into science, it's, as a child, I really enjoyed the topics or something, or maybe they have like a teacher or a parent or something like that. So in your case, you didn't have maybe that person that was sort of an inspiration or an influence, but your experience of malaria drove your curiosity. And I'm just curious as to, so those experiences that you had being sick, going to the hospital, probably kind of negative at the time, right, have now become this sort of positive sort of motivation for you. Do you think that sort of drives your work? You're wanting to help people with your work?
Yeah, I mean, for me, I think, we'll come back to this later, but, I have had opportunity to work and live in abroad. But I'm always drawn to be back home, because this is where the problem is. This is where the solution is needed most. So just studying a problem that is very close to the community, very close to the people, that touches you every day, I think it's a different motivation. And for me, also, even the fact that I can have a conversation with a doctor and I understand the decisions that the doctor is making, because they have to, evaluate all this evidence and make all these choices. For me, that's really important. So I think the most important driver is, for me, I'm drawn to working with the people, working where the problem is. And I don't think there are people who needs to do it than us ourselves, who are very close to the problem. Most times than not, we have our problem defined by different people, solutions defined by these people, and we are told to implement this. And I mean, now the conversation has changed, and I'm happy I'm doing science at this time where the conversation has completely changed. Over time, people are appreciating that the people with the problems are the ones who should, define the problem and come up with the solution. And that conversation is really important for us. I mean, you, an example, you in Canada trying to understand malaria, and me here, you know, dealing with malaria every day, seeing the people that I know, my community having this problem. It's different. The motivation is different than, studying a far-fetched problem that you cannot connect with. Yeah.
Mm-hmm. Yeah, I think that makes perfect sense. And I know I've had colleagues that, they're from Europe, and they did studies in the UK where they worked on things like malaria or schistosoma, in places in Africa. And they themselves kind of got a feeling that the people that were in Europe were not connecting with the reality of what was going on. It's like they went there and they collected their samples, they got their data, and then they left. And they wrote whatever paper that was going to get them, something, but there was no real connection to the community. One friend of mine actually said he thought it felt a little exploitative. It's like, yeah, okay, you could say in the big picture, the knowledge that we're getting from this data, from these samples, will be published and it'll be available to everyone, so it should help. But it was more almost like, I don't know, science tourism or something, kind of, where it's like, we're going to go and we're going to have this field trip to wherever it is, and we'll get these samples, but then we'll never talk to those people again. We'll never, there's no connection there or anything like that. You say the conversation is now starting to shift, and I think that's good, because again, who knows the questions and the situations and different things that an outsider wouldn't know than the people who are there, right?
Yeah.
So how do you feel about this relationship then now? And maybe you can talk about some of your experiences going abroad to study science. But do you think these kind of collaborations between big institutions in Europe or the US or whatever, with places like Kenya and yourself, how is that all changing?
It has evolved a lot. It has evolved. We call it actually helicopter science.
Helicopter science. Oh, great. Way better term.
And even journals are increasingly demanding that you cannot publish a paper from Sudan, for example, without people from Sudan. How does it make sense that you are in a X university in abroad and you are publishing these very good sequences and drawing all these inferences without the people there? So how did you even collect the samples? So I think for me, the things have changed over time. I mean, during the early days when I went into science, the negotiations the PIs had with our northern partners has evolved over time. For example, a simple example is that over time, we are no longer always shipping samples. We have to ship samples for technologies that we truly, truly don't have and that will add values. So we are now seeing that loopholes. Like now we can do most of the things that we really need to do. So why are we shipping samples abroad? And even when we are negotiating, I've had instances where people want me to do a study, but the way they want me to do it, I just can't do it. I'm like, I'm the one on the ground. I'll tell you this design cannot be done it this way. It has to be done this way. This is culturally, this is how we do it. This is the cultural appropriate way of doing it. So that has informed even when I'm negotiating for grants, and we are constantly, this relationship is sort of skewed because most of the money is coming from the north to us. So sometimes, we don't have much say on these negotiations, but with time we are increasingly pushing back and saying, okay, fine, you're bringing the financial resources, but this is how we want the science done. We still have to respect our people. These ones we can do, these ones we can't do, or we can do it this way, in our way, not the way you're proposing. So I think over time we are gaining confidence, and there's a lot of support, and people are trying to understand. And so yeah, as long as the ones who pays the piper, if the one is paying the money, has calls the shot. But I think there's a lot of push towards equity, towards respect, and mutual understanding and respect when you're negotiating for these contracts and these grants. And there are things that we had instances we are saying no, we just can't do it the way you want us to do it. We are not able to do it, and we are happy. You can walk away from, we are starting to appreciate that you can walk away from a grant, you can walk away from a contract, you don't have to do it. And when it's coming to us, we are doing it in our way. We will answer the same questions. It's just that we will, use different ways to reach to the end, at the same time respecting our people and appreciating the people who inform the work that we do.
Yeah, it sounds like it's probably like an exercise in building trust too, right?
Yeah,
Both
yeah, yeah,
ways.
yeah, yeah.
Because I can imagine, just to kind of like try and put myself in the situation of someone who's from the north, let's say, that has this money, and that they're probably really concerned, like, are we going to get what we need from what our needs are, and is it going to fit in with already published things? There's that thing in science, right, where you want to do things the same way as someone else did so that it's comparable and all these things. But again, it's like that leaves out the human element. It leaves out the realities on the ground that you might have to deal with that they don't. So then there has to be this sort of trust that, look, we can't do it the way that you've done it before, or we can't do it in the way that you've written it, but we're going to get to the same thing. Like you said, we're going to get to the same answer. And I would think that you would even have, if you trust your partners on the ground, yourself and your colleagues, you're even going to get more, because you guys will have insights and will be able to ask questions that someone else hasn't even thought of, right?
Yeah, and we don't compromise on the rigor at all. Uh,
Hmm.
that's out of question. And sometimes a good case in point is that every time we have collaborators and we are in meetings and we feel like they're just speaking like they have no idea what's happening, we invite them to come and see our labs and see the way we are doing science. And they some of them were shocked and surprised that we have all these facilities, and sometimes we even have better labs than some facilities there. So we are not trying to, for lack of, description term, like cut corners. We just want to do science
Hmm.
that is respectful, use our people in a respectful way, but we do competitive science like any other place, and the rigor is still the same.
Yeah, yeah, and I think that's what I mean is that there's like, yeah, maybe just a lack of understanding probably, and it's good that people are coming to visit you there and see the facilities because again, like I understand this. One of the universities I studied at had a program where they would every year groups would. There was a professor from Ethiopia that was now at our university, and every year he brought students back to Ethiopia to help with molecular biology training and stuff like that. And everyone always came back with this like, it's not what I expected, the because I think there's still this in ingrained stereotype that yeah, like that the resources aren't there, right? And so therefore we have to be worried about is are things going to be done correctly? And I think yeah, it's probably an outdated notion, and people need to maybe visit more,
Yeah.
or just like you said, like or like I was saying, like build this trust of it's these are your partners, these are your colleagues, and where everyone's pulling the rope in the same direction, so to speak.
Yeah, actually, and you see there an evolution of how they treat you. Like when you start in year one, the kind of notions they have, and then now you have collaborative. People are moving between sites, and third year, fourth year, they're relaxed and they're like, oh, okay, it's like their notion of the way the things are were different. So they start appreciating and and seeing that we actually doing at par science, like like anyone else. So I think that collaboration and visitation is also so important. Just like for us, we go abroad just to learn new technology, experience new culture, see how things are done, how scientific questions are answered. So it's two-way. They also need to come and see where we are, how we work, how we do the science, and how we do it. So in a way that they see that, oh really, this is the same work that can be done in lab X in another institution can be done here. Yeah.
Yeah. I just have one last sort of point on this now that we've kind of dived into this area, and it's I was thinking about these questions, and in science in general there's whether you're in I don't know how it works in Africa and Kenya where you are, but when I viewed it and was in it, and in Europe especially, I think there is a very strict hierarchy. Like there's, when you enter as a PhD student or as a master's student or something, and then there's the professors, like there's a really kind of defined hierarchy. And in a way, I understand that because you're when you come in, you don't know all the things that you need to know, right? And you need to learn. But I was wondering about how this maybe trickles down into these relationships, right? Where there's still maybe this view of this hierarchy of like, the places like Cambridge and Harvard or whatever it is, right? That they have this, but it's I don't know. It's not like that, and in reality, it's not like that. And I don't know. Do you feel that? Do you feel that science in general kind of has this sort of ingrained hierarchy in maybe like the culture of it?
Yeah, I think it is. It does, and even when I think that hierarchy is very clear in universities, for example. I mean, for universities, it's very clear. I'm a professor, call me a prof, call me prof. I'm a doctor, call me
Hmm.
doctor. I think that hierarchy is still there. I'm not sure whether that it does affect students. I mean, the way you relate between students and lecturers, for example. But I think for us in a research institution, of course, you acknowledge the hierarchy of someone that they have, but then it doesn't interfere with the interaction. And once you have been in that environment for long, and then you sort of get into the culture and the way they relate, I think you can still navigate. I'm so lucky that in the institution where I work in, I think we've broken those hierarchies in a way. So
Mm-hmm.
we don't use titles for people. We interact almost at the same level. But I know that these hierarchies are still there in universities, for example. But most research institutions are slowly moving away from that. And in fact, now that we are moving towards more collaborative science and research, and there's a whole push towards mentorship, I think increasingly teams are being asked to work with, even the entry people, early career researchers, all the way to senior people. And having those diverse teams, I think, is going to help break those kind of hierarchies that have existed there for long.
Mm-hmm. Yeah, and I'm thankful, like, to be clear, that, like, in my experience in my PhD, the lab that I worked in was very collaborative. Like,
Yeah, yeah,
again, there's always, in every job you have a more experienced person and a less experienced person, right? And you need to respect
yeah,
that knowledge difference and be able to learn. But yeah, it's if you keep that strict hierarchy, and you might be missing ideas and insights from less senior people, let's say, but they still have good ideas, they still have good perspectives and stuff. So it's like, if you have that strict hierarchy, you're not going to get that. But yeah, and I guess I'm just trying to think of, like, maybe that's kind of a bit the situation on the global stage, and that we're breaking that down, I would hope, and that it's more, yeah, collaborative. It sounds like it's moving in that direction. I want to ask, though, about your experience then going abroad. So where have you gone? I think you were in the US, you said, once. And yeah, so why don't you give us where you've been, and then what was your perspective in terms of, like, what did you learn from going abroad, or what was something that you thought, like, oh, they do it this way here, but we actually have a better way? Or I don't know if you have any specific examples, but you can just give your impression, I guess, of your time abroad.
yeah. So I did my master's from London School of Hygiene and Tropical Medicine, but then we had these distance learning programs way before people went into virtual learning. So my master's was purely distance learning, and then my PhD was in the Open University in Milton Keynes, in the UK. And again, our center is sort of certified to train and allow people to do their PhDs on site. So then I did it on site, so I didn't go. But then I got an opportunity to go abroad for my postdoc. My first postdoc was at the NIH in the US, and then I did another postdoc in Oxford, in the UK. So what have I? I've learned a lot in these two places. In the US, I mean, there you get to sit with all the, everyone collaborates with NIH. You get to sit in meetings. You have these funders and all these people that you will not ordinarily sit with. And then you get to understand that how people are answering questions and how creatively they're designing their studies. And you get to appreciate why these people get to publish in Nature, in Science, and all that. And just understanding how people frame their questions. And of course, they have access to, equipment and facilities that we don't have, but then just interacting with them and getting to see how they answer their questions and working with them, seeing how they analyze and they get their papers to very high impact journals was really, eye-opening in many ways. Then, when we here where I am, where the kind of science that we do, most of the time it's more of basic science, trying to understand basic epidemiological questions and trying to define or characterize the virus or the parasite, and understanding immunity to the parasite, for example. But in the US, people move towards discovery, patent, and drugs, and like the gap
Mm.
towards, the end of science is very close. And you see people move from the lab to the bench. You see how people discover a molecule, go all the way through this basic discovery science to the animal models to human clinical trials. I mean, NIH has a clinical facility, and they can make their own vaccines and test them in humans, and then they move them now to epidemiological sites, in African sites, to test them now in real world and provide real world evidence. So I mean, you get to see the entire spectrum, like than when I'm just answering an immunology questions in Kenya. And that's our strength. But although we are building the strength towards doing more work, but our strength is in population research, understanding, population dynamics
Mm-hmm.
and epidemiological dynamics of a disease, for example. Then I went to Oxford, and I was in a biotech company. And in a biotech company here, they're like, okay, every asset we have is our worth. Like, even our lab assets, the lab assays that we do at our, advantage, competitive advantage. This
Mm-hmm.
is how we do it, and this is how we move. This is how we move from the lab. This is how we discover molecule. This is how we screen all these 1,000 molecules to know which one we're moving forward, and then we move that, and all that collaboration. So I mean, for me, being moving from Africa, US, the UK, it's just a totally different understanding of science, and appreciating the whole spectrum of science, and then being in the UK, and then you're talking about money, you're talking about all these assets, this is how much it is, this is, you're talking science is translating into money almost. I mean, their process from discovery to clinic to costing that intervention is like real. This
Mm-hmm.
quarter, this is what we are looking for. These are QA results. It's exciting in many ways, and I'm happy and I'm humbled that I've had opportunities to do that. So for me, I've seen the entire spectrum, and it is informed the way I also think, and also the way I
Mm-hmm.
design my studies here. And it moved from the idea that, oh, science is for the goodwill, which is what it is, but science can also be money.
It's a lot of money. Yeah. I mean, I think no, you're absolutely, I see how, seeing that whole spectrum of, a place like NIH where it's like the drive really is towards translation. Like, how are we going to get an actionable treatment or something out the other end, right? And then the same with a pharmaceutical company, like that's even more, right? Like they have to make money, right? And it's something that in science there's like this tension, right? Because a lot of scientists, they have this image, or even people that look at scientists, there's this image that it's all curiosity, it's all discovery, it's just this joy, this wonder of like, we're just finding things for the sake of it, obviously helping people with medical treatments and stuff. But there's so much money that takes, that you have to make money in order to keep doing this. I mean, or you have to have taxpayer funding it, right? Like there's just no other model that's going to make it like work. But again, it's like this, sometimes if you lose that perspective, I think maybe um when you're talking to people about science, or when people are trying to understand the motivations of scientists, it's like, if without being honest about the money question, it things that's where things can get like, you know, misconstrued, let's say, by the public. That's why maybe you see these things, that are so
Mhm.
successful in the US about, well, they just want money, like whether it's climate change or whatever, like they've invented climate change just to get money or
That's
something,
true. That's
like.
true. Yeah. There's that push that, science and discovery, even the discovery that pharma uses, is funded by taxpayers. So we get money for free, we make discovery, then we bill people. So there's always that. But
Mhm.
when you're sitting on the pharma side of it, it's like return for investment. We've put in a lot of money.
Mhm.
We've invested millions to get this small molecule. So we need to get a return for our investment. So there's always that.
Mhm.
But then again,
Yeah.
you don't have to, science should not make you poor.
Yeah, yeah, yeah. Well, and that's the other thing. And I mean, this is another thing that we could talk about in terms of, maybe a problem with science. But I know something I really realized going from North America to Europe. So I never actually did science in Europe, but my wife we came to Europe because she did a PhD and now has been doing postdocs here. But just seeing the way that, and this is a bonus I think for Europe, but the way they pay
Yeah.
PhD students and postdocs is like, it's a valued
Yeah.
job, right? Whereas in the US and in Canada, you're kind of expected to live very poorly, as a postdoc, and it's all about, well, you're going to get the payday later. You're getting this beautiful experience, you get to work in this lab, so that's your pay, is all of that stuff. But you have to live like, you know, on toast and crumbs, like it's, whereas in Europe, it's like, no, it's, you have this many years of education, you have this much experience, so therefore you're in this bracket, right? And it's like, it's very logical, it makes sense, right? But for like my wife and I, we couldn't have our two kids, on a postdoc salary, and in Canada or the US, for sure it would have been like very difficult. Yeah.
Yeah, I mean, in the US, now there's a push actually, there's a push in the US for postdocs' terms of service to be improved. And it makes logic sense. I think it just, it's a lot of effort to finish a PhD. Honestly, it's a lot of
Mm-hmm.
personal sacrifice to do a PhD, and just so that you still live paycheck to paycheck as a postdoc. For me, I'm unable to reconcile that. I feel like we deserve a decent pay, and it's just not so much to ask for. I mean, it's just fair
Yeah,
enough.
exactly.
Yeah, science doesn't pay. I mean, you publish a paper and it's free. The journals, not to go into that argument,
Yeah, that's a whole. We could do a whole nother episode on the what the journals are doing. Yeah.
Yeah, yeah. I think it's a fair ask that we just live a decent and we do hard work. Science
Mm-hmm.
is hard.
And
Yeah,
that the knowledge that you produce in
yeah,
your PhD, it's all open. Again,
yeah,
we have this problem with the journals making things
yeah,
paywalled and things like that. But really, like all that hard work that you've put in is published for anyone else to use,
yeah,
right? Like it's not
yeah,
copyrighted. It's yeah, sure, the universities probably have some, control over different things, but yeah. So the idea that then that you don't get paid for that is, it's a weird one. It's a very weird one. Anyway, we could go on, we could go on and on. I wanted to just go back to your childhood, let's say, or growing up, your experiences growing up, and because you didn't have, let's say, like you said, there was no one around you that was a scientist. You never interacted with a scientist. But I want to look at it from the other way. What are some things, maybe, if there is, that you got from your community or your family that has now helped you with your scientific career? Maybe something you didn't think of, but now you can look back and say, it's the people in my life or where I came from or these kind of things, like, really I'm bringing that to my science. I'm bringing that to what I do now.
I think the thing I've learned from my community is that the work that I do, can I see it translating to, improving people? Because honestly, the science we do cumulatively, let's say you do basic understanding, you find maybe a gene, and if this gene is disrupted, there's a disease risk to it. For a pharmaceutical company, that's the basic science they need to rectify that molecule, or to tweak around the molecule so that they can restore the normal process. So growing up in a community where you are cared for and supported, and for us, we are very communal here, and I think that's the first culture shock you get when you go abroad and everyone is quiet, no one is calling you after work. You're like, what? For us, we are very communal, and we are so much into other people's spaces, whether that's good or bad. You miss it when you don't have it. Anyway, the long story short is that just seeing that connection of, for me, I've had to find a connection of, that work I do to the people. And so sometimes science communication allows me to do that. You go to the community, you get samples from these people. You are in a hospital, you get samples from these people. You need to go back and tell them why. Like, why is it important? Why is it important? The questions that you want to ask, and how does that translate into their life being better? I think now more than ever, people are realizing, unless scientists start shouting, no one is going to appreciate what we're doing. And no one is, and science is for the public, by the
Mm-hmm.
public, for the public. We depend on goodwill from people to allow us to do the kind of work we do. We cannot go to the community, get samples, or do all this manipulation we do if the community does not allow us to be there with them. So
Mm-hmm.
that connection, for me, I've tried to find connection, or if not, then connect to the policymakers who have the money, the resources. They don't have unlimited resources. They have constrained resources, and they have to make a decision on where it's most important. So providing that data for them, like, this is where if you invest here, this is where you're likely to create the highest impact. So I'm
Mm-hmm.
able to see my science from the community and see that my work really moves in both ways. If I cannot provide an intervention, then let them know that the work I do is important, and this is why it's important, and this is why we need, actually, without the public allowing us to do the science that we do, we cannot do the science itself. So we need a
Mm-hmm.
lot of public goodwill. We need people to agree to us, to get samples from them, to agree to us, to test these interventions. I mean, I don't want to use the words that drive mistrust in science, but technically, when you have a drug, people are taking the risk, for the goodwill. you
Mm-hmm.
know
Mm-hmm.
that's
Yeah.
what
Yeah. Yeah.
clinical trial is all about. that you have to convince someone to be the first person to take this drug for the goodwill of other people. And so, and there are many clinical trials that don't see the light of day, because from the first early trials in humans, it's a no-go decision. We cannot produce. And those are people who have really trusted us to test that in them.
Yeah, that's a good point. And I think it's when you think about like medical research and sort of the infectious disease, that kind of stuff, the science for the good of the people, really, it's more obvious, right? I love that you highlight that other side of it, though, that it is like you're going into people, maybe in the hospital or whatever, when they're in a very vulnerable position, and you're saying, hey, can I take some blood or this or that, and they're probably oftentimes scared. Maybe they don't know exactly, what this disease, all of these things, right? So it's a very, you have to be very respectful and understanding of that. And then again, you're asking them like, hey, will you be involved in this trial, which is, as the word says, a trial. It's not a guarantee that it's going to work and all these things. So it's a very delicate thing. I just wanted to say, though, that it's like, I think science in general, right? Like whether it's physics or all these things, it is for all of us, right? Like that is kind of why we do it as humans, right? And I think that's something that globally, like no matter where you're doing science around the world, that's sort of a universal, right? Is that there's this idea that we all want to understand the world around us and why it is that way. And in doing so, we invent useful things. Sometimes we invent useful things that have harmful consequences, and we need to maybe consider all these things a bit more. But it's I don't know of how many other professions that really have this problem of like, we have to convince people that we're doing a good job, like no one else really has to do that. But in science, this science communication issue is huge, right? And it's like, you want to do all this stuff for humanity, for society, but yet we still have to be out there being like, please listen to us. It's a good thing. We're doing a good thing, or give us money or whatever it is.
Yeah, but the reason why we are where we are is because people in the past, science was shrouded in mystery. We never allowed people. And one of the things that I did for my first science communication was to do a virtual reality of the labs. Why not take the lab to the people? Why not people see what we do in the lab? For so long, people never understood what we did. And so you can be on their side when they're like, they don't tell us what they're doing. So what are they doing with the blood? Why are they doing all these things for most of which we never even get to know what they're doing? So for all those failed experiments, they probably never know why. We never tell them. So science was built in a shrouded way. But now I think this is, in my mind, this is what may have, made it, created this science communication, area, so that people really understand what we do, why we do it. Yeah.
So we kind of now touched on like why you've kind of got into science communication, or why you see the benefit of it. I want to talk about the article that you wrote for Nature News, I believe, calling for science journalism in Africa. Africa needs to invest in science communication. Here's how, I believe, was the title. What was your motivation for writing that? What do you see on the ground in Africa that you think needs to be changed?
I think we're doing great science, and no one is saying what we are doing. People don't know the kind of work that comes out of Africa. Most times, some people know. To be fair enough, some people know, but some people, there's also a big population that doesn't know what we do in Africa, the science we do. I mean, we have contributed to so many interventions that are used globally. For example, the HPV vaccination. It's a vaccine that is given against human papillomavirus, and it's given to teenagers. So they used to give 3 doses. And we did study here that contributed to showing that 1 or 2 doses is enough. And that has changed the whole intervention, because now the young girls and women don't have to go to the hospital 3 times. Just with 1 shot or 2 shots, you're good to go. So there's a lot of science that happens here, but it never gets to see the light of, okay, it's published and in journals, and journals have their own audience.
Right.
but other people don't get to see it. And science journalism offers this platform. Imagine if our studies are covered in these big magazines, or that have global distribution, then people start to change the notion. And then who is telling our stories? Why are we not the ones telling our story? As long as someone else is telling a story from somewhere in the computer with this imagination of how we are doing the work we are doing here, what kind of story are they going to say? So we need to be the ones saying our story. And that matters because it shapes the perceptions. And sometimes you go in meetings and people are freaking out. They don't even know whether you'll be able to do a presentation, because they can't imagine, like, you're fresh from Africa and you have this global conference and you're presenting. People are nervous that you're presenting, because they're so scared you're going to make mistakes. And then they're like, oh my God, that's good work. Like, they're surprised that you're doing that good work. That's the kind of narrative that we really need to shift and change. And it takes a story at a time to change that kind of thinking. I think we've not had the global platform to say our story. And I think opportunities like publishing in Nature and all those provide us the global platform. But then that's why we need to say the science stories. But the reason why I did the publication is just putting a case to all these developed countries are way ahead of us, because they are doing their science communication in this way. For us, as long as we are not doing our science communication, no one is going to know. Our governments are not going to know the value of investing in science if they don't see what the science is doing to the people.
So you're saying, I mean, I imagine that there's multiple audiences that you would say that you need to reach. But first and foremost, it's, if you're not telling your story, who's going to hear it? And then again, these notions that we talked about at the beginning, this sort of, well, the scientists from Africa, that it's not, the work isn't as good, or they don't know, this kind of, that stereotype will persist because nobody knows all the great stuff that you're doing, right? But is there an internal audience as well? Like, science communication needs to get better for the people living in Africa themselves.
Oh yeah, absolutely. I mean, in the absence of that, we have misinformation and disinformation fueling. I mean, if a conspiracy theory now with social media, they say it's a global village, misinformation or anything circulating in America, it just takes a few days and it's in Kenya. So we need to provide, even with our population, we need to provide them accurate scientific information. They need to know that, oh, if I have this info, if I want to find out about this is the reliable source of information to go, or this is the kind of work that is happening in our country. Or they can be able to even know, like, oh, this is not true information, this is actually fake. They should be able to know, okay, where is the source of true information, factual, accurate information. Even that is important as well. And as well for them to understand the kind of research that is happening in their country, and sort of drive that goodwill that we need to keep doing the science that we are doing. So I think it's both ways. We need our people to understand what we do, but you also need the global audience to appreciate that we're also doing competitive science like anyone else.
Yeah, that makes sense. I want to focus again on the African audience, the African population, because I just want to understand this. I think social media it's ubiquitous, right? Like, it's all over the world, and we see the problems with that all over the world. And no country is immune to this, I think, misinformation, disinformation thing.
Yeah.
Many places like, Canada, US, UK, we probably thought we were immune to this, but it's not. Like, you see how fear and, the lack of information that can leave room for all of these things to grow. Is there something in addition to that that maybe drives distrust or misinformation in Kenya and Africa, or are you grappling with the same problems that we are?
I think there's also the angle of religion. I think we are more religious than any other society.
Well, the U.S. is a very religious place as well.
Try us. In fact, in every village there are even like 10 churches, different denomination. I think. I think without going further into that, because of our standing about religion, but I think also religion can contribute in a way, because if a church leader comes and says, don't take that vaccine, it will take us so many years of so many conversations with the community to undo that. as long as they dispute scientific evidence. And there are times, this is me being very cautious. There are times when science and religion, and it's been documented, don't necessarily agree. So when I go to the community and ask like why you not taking the vaccine, they'll say, oh, in my church, people tell us not to take this modern medicine. I mean, in a minority of population. Right. But yeah, I mean that people's cultural beliefs, religion sort of also influence the way they process information. And sometimes they tend to rely on what the Bible says or what the pastor says, most of the times what the religious leaders say. And so if the religious leaders contradict science, so we are in trouble. For scientists, we are in trouble there. So we have a whole mix of things that are contributing, and some of factors that are very unique to our setting, and not to mention socioeconomic dynamics, gender dynamics, and all that stuff as well.
So then, I guess, do you have strategies then for dealing with some of these contentious things, like trying to get maybe those influential people in the village or in the community, like do you go to them to try and convince them, and then they can spread the message? I guess I'm looking for, do you have ideas or strategies or tactics that you use in your science communication in these situations that again then other people could use around the world?
Yeah, you're right on what you're saying. So we position science in the community. So we take science to the community. We use community radios. We use these community leaders. These are the first people that we use to engage with them about science. So we position our science in a different way. We try to have programs and conversations with the community, and we try to let the community know the kind of work we are doing. So there's a whole body of community and public engagement that helps us to position ourselves in the community, and sort of sometimes use these platforms as ways to try and counter the misinformation that is happening. So our science is no longer you get a grant, run the project, and that's it. Position is get your grant and take the science to the community. Let the community support the work you're doing, understand the work you're doing, and all those engagement platforms also helps us, counter those misinformation, and finding creative ways of communicating science. You can use radio programs, that's for adults. For children, you'll try to use videos, animations, and all that. So science communication is versatile. It gives us all this range of tools that we can tap into depending on the audience that we are engaging with.
Yeah, I think that idea of embedding the science in the community, I mean, the nature of your work, you have to do that. I think kind of what you said at the beginning, the three facets of your work is you need that sort of community. You need their help, and you're providing help to them, right? Like it's a mutual relationship. So you're really embedded in it. But I think in a broader sense, just the idea of embedding science in communities all over makes more sense. Like this is where people are going to really get that understanding. And I found that in my experience, some of the most fulfilling, and I think I don't have data on it, but my feeling, the most successful science communication stuff that I've ever done was face-to-face, in person.
Yeah.
Right? It was at the museum, it was at whatever it was, and then you can have that conversation, and those people they can see you, they can talk to you, you can see that maybe they're a little nervous to talk to somebody at first because it's like, oh, a scientist, like I'm not going to understand what's going on. There's that intimidation, and then you just have a normal conversation, and they can ask their questions, and they can be heard, and things like that. So I think that's a lesson I think that all of us could take, is that embedding the science in the community where it's done and where it's going to be applied, kind of thing, right?
Yeah, that's true. And their concerns are valid. Just even listening to them. I had this vaccine, I got these reactions, I discourage people from taking the vaccine. Trying to understand, okay, and explaining to them that these vaccines are good, but for a small proportion of the population, they're gonna not react well to the vaccine. So when they tell you their concerns, you should listen. Providing that mutual platform where people can listen, can air their voices, their reservations, and having that conversation without judgment, providing a safe space for them to get feedback to you. I think that's also important.
Yeah, absolutely. I think that's a good lesson to take away. We've been talking for an hour, so we can start to wrap this up. I just have a couple more for you. where, I guess, let's just say, if you wanted to give the message, to people outside of Africa, what's going on in Africa, what to be excited about in terms of the science that's going on, what would you point people to? Where should they go? Maybe even visit, or do a little research on. Are there different, maybe cities or areas where things are happening, and what kind of topics are being researched, discussed, that kind of thing?
Wow, that's broad. But I think
Sorry.
I think the first I think for scientific community, I think if they're reading a collaborative research paper, they should try to do a search about the institution where the paper has been published from, and trying to understand the scientist and their profile of the scientist. I think for scientific community, that's not a problem. It's very easy. There's so many papers that we churn out. You can even say research in Kenya, and you'll see all the institutions and the kind of research they're doing, from agriculture to health to climate change. So, I mean, that interest alone can lead you to papers and all that. But I'm also, the other thing that I'm trying to do is create a platform for journalists between Africa and the global north. And I appreciate this platform for you to dig and look out for me and interview me. It's a step towards trying to give us the platform that people can understand the kind of work we do, and just see that we are equally trained like any one of them, and doing rigorous research as well. So, and also having platform for journalists to appreciate that when they're reporting about science, I mean, now we have AI models digging information from thousands and billions of information on the internet. So even our own our own journalists, when they do stories and they cover work from our areas and they cover our diseases, how do they do that? What's the story? What's the angle? And the angle makes a whole lot of difference. If you create us as, this picture, that's what people are going to stay with. So we also need to have angles that are factual, respectful, but at the same time highlighting our issues, not in a demeaning way, but in a respectful way as well. Yeah.
So this platform that you're building for journalists, maybe you could explain that a little bit more.
So I got funded from, first of all, I won an award from the National Academies.
Congratulations.
Eric and Wendy Schmidt. It's a long one. Excellence in Science Communication Award. So this is an award that is given by the National Academies of Sciences in the US, where they recognize excellence in science communication across the world. So they chose one of the product that I produced, which was an animated VR video about the COVID-19 pandemic. And the goodness about that award is that it gives you global platforms. So they follow us throughout, and they connect us, give us networks. And through that award, I've been able to have collaborations between universities in California, a university in California and Kenya. So they fund some of these projects that we do, and it's through that kind of collaboration that I got to write the Nature paper as well. So I got to be mentored to produce such a paper, because imagine the way we write, and the way we write stories for our audience may not be necessarily the way you package the story for a global audience. Yeah,
Right.
so getting that mentorship to write and produce that kind of story, and that paper really got, I got kind of the buzz it got in social media was very good. So all those platforms, and for me, every opportunity I get to have a bigger audience, a bigger platform, a global audience, I use it, because then we need people to be there, and people will be curious maybe, and then try to dig and find out about us. So creating platforms for people to interact, have people from there also coming to visit us and see our research institution through such kind of platforms. I think they're creating the kind of platform that we need to change the narrative that we currently have,
Yeah, no, that's great. Yeah, thank you so much for taking the time. I really appreciate it. And again, I think that I'm very curious. Like I said, in recent months, years, I really started thinking more about how, people think of science, they think of that person, probably an old white guy in a lab coat, whatever, that sort of, stereotype, but also just the idea that we're all doing rigorous, good science, right? Like that scientific method that doesn't really change from place to place, but how you come up with questions, right? Or how you see the nature of a problem, right? Really changes depending on where you're from, your culture, your experiences, the realities of where you are on the ground, geographically, all of that kind of thing. And it's kind of this, again, we talk about the sciences being these artistic profession, right? All of those human factors go into science. And a lot of times we don't think about that. We think it's just everybody does this hypothesis testing, and it's this like cold machine that just produces facts out of the air. And that's not really how it works. It's a very, very human pursuit. It's a very human thing to look at the world around you and say, why? How can we figure that out? How could I make this better? That kind of thing. And so I'm really interested in exploring, all these different places where people are doing this stuff and trying to get, these different perspectives. So thank you for sharing your perspective with me. I really do appreciate it.
Thank you. Thank you.
I appreciate you taking the
Thank
time.
you for having me. Just one last one. And think about it. This is where we have this before we were, sort of banned from using diversity, equity, and inclusion, before it became what it is now, polarized term. If, say, a pharmaceutical company wants to explore to them African markets, they cannot do it. They need people from there to help them, access that market. So in a way, and even when they're designing, and now it's increasingly becoming important that everyone's genome is represented. If you're doing a clinical trial, do a clinical trial across the population types. We are all different. Right. We are all diverse. So get our diversity information to feed into your clinical trial, to feed into your drug discovery. So, I think that kind of conversation is pushing people to move from their comfort zone, I can say. That now if I'm doing a clinical trial, I have to ensure that all these different people if my medicine is truly to, if I want to make money, if my medicine is to cure humanity, then the trials have to reflect that you have to have all these different people reflected in the trial. Then you're making information about approval for that drug when you understand clearly how that drug is going to work across the population. So I think that push is what we need, and I'm happy that people are starting to have that kind of conversation as well.
Great. Well, great message to end it on, and I'll say you're welcome back anytime when you have an exciting new study or just some other topics that you want to talk about. You're welcome back anytime. I really, really appreciate you taking the time.
Thank you very much. Thank you for having me.